online faculty development program on recent trends. Good afternoon, participants. Welcome to 1 week national level online faculty development program on recent trends in cyber security and machine learning. Welcome one and all. As a part of this program, I request Seema Sharma madam. First of all, from the Department of CSC, Sri Vishnu Engineering College for Women, we thank you, ma'am, for sparing your valuable time to share your knowledge to our participants as a part of this faculty development program as a resource person. Thank you so much, ma'am.
Thank you, sir. Thank you so much.
Yes, ma'am. Before entering into the session, let me take the privilege to introduce you, ma'am. It is my great honor to introduce Dr. Seema Sharma. Dr. Seema Sharma is currently working as Assistant Professor in FCA MRI RIS College. She completed her PhD, MPhil, MCA, BA Honors in Maths. She has 16 plus years of teaching as well as industry experience. Her research interests are data structures, software testing, and genetic algorithms. She published 15 plus national or international journals and attended many national conferences. She has more than 4 patents in national and international. Really, we are lucky to have such a great person as a resource person in this faculty development program, ma'am. Ma'am, now I request you to share your knowledge and insights in understanding artificial intelligence and machine learning. Over to you, ma'am.
Thank you very much, sir. First of all, I would like to thank you, Shri Vishnu Engineering College for Women, for giving me this opportunity for this FTP. And I also want to give my special thanks to Dr. Professor P. Kiran Sri, who has invited me for this FTP. Thank you very much, sir.
It's our privilege, madam. Thank you very much for being part of this FDP. Please.
Now, is it my slides are visible to all of you?
Yes, yes. Slides are visible and you're audible. Please proceed, madam.
Okay, thank you. The topic of my FDP is linear regression using machine learning. But before going further, I just want to give the brief introduction about the artificial intelligence and about the machine learning. So nowadays, in today's scenario, that we have seen that this artificial intelligence, this keyword, this has very far surpassed the hype of the blockchain, quantum computing, etc. Why? Just because we have the huge computing resources, and these huge computing resources are easily available to the common man. If you are talking about this huge computing resources, they can be used by the developer nowadays, and they use these computing resources in order to make the new machine learning model, as well as they can also apply this these resources, or we can say these data, into the refinement of the existing system. For example, in order to get the better performance of the existing system, in order to get the better results from the existing system. So if we are seeing that nowadays, when a IT professional that have a machine learning skills, they are highly in demand. So as I've already told you about that we use artificial intelligence in our day-to-day life. So I will just share some of the examples with you. When you will tap some face in a Facebook photo, and it will automatically detect all the faces that are available in the photograph, that are available in the picture. How it can be happen? There is an artificial intelligence that is running behind the scene. Is it that it will only detect the human faces? No, it can detect any of the object. It can be detected any cat, it can be detected the image of any dog, the image of any bottle, the image of car. So there is an artificial intelligence that is running behind the scene, which will be able to detect any of the objects. Take another example. Suppose when you are traveling, you use the sometimes you may use the Google direction map. That will give you a best possible path, and you will follow that path. How it can be possible? This can be done by the artificial intelligence only. This artificial intelligence that gives us a real-time traffic situation. Now we are talking about the Google translation. Now, when you will use this Google translation, this app actually helps us to communicate with the local people speaking language which is foreign to us. And how is this possible? This is possible only through the machine learning concept, only through the artificial intelligence. So in our day-to-day life, there are several apps of artificial intelligence that we use practically today. And in today's FTP, I just want to discuss the linear regression using machine learning. I will discuss here what is machine learning, what are the data and what are the terminology that will be used in order to implement the machine learning. What are the types of the machine learning? Out of that types, I will discuss the supervised learning. What are the methods that will be used in order to for the supervised learning? And what are the statistical tools that will be used in order to implement a linear regression? So I will come to the point that what is machine learning? In a broad term, that we can say that this machine learning, it is nothing, but it is just a branch of the artificial intelligence. Actually, a machine learning, it encompasses a lots of things. This field is very, very vast. And nowadays, it is expanding rapidly. This machine learning, it is just a field of the study that gives us the computer algorithm, the ability to learn without explicitly programmed. Yes, that I have mentioned here that machine learning is nothing but it is a science that will make the computer learn from the previous data without explicitly program them and improve their learning over the time in an autonomous fashion. Now, when you are talking about the computer algorithm, now, if we see that normally what will happen, we use a computer algorithm to solve the problem. Whether I will prefer the top-down approach or the bottom-up approach, but the computer algorithm is actually used for evaluating, for solving, for solving the problem. For example, suppose I want sorting, I want searching, I want to evaluate or finding out the best web page. Then I will use this computer algorithm. But when we are talking about the computer algorithm in terms of the machine learning, it gives us the prediction, the output of that algorithm that gives us the prediction. Prediction means forecasting the anything. Okay. Now, if I want to evaluate, if I want to predict the accurate outcome, we have to know something about the past or we can say the previous behavior on the basis of which we can evaluate the correct prediction. Okay. Now, when we are talking about the past or the previous behavior, then we use some data and that data is known as the training set. And this training set data is very, very important. Now, any of the machine learning algorithm, there are three steps normally that will be used in order to develop any of the machine learning algorithm. The first step is that you have to develop the generic algorithm. When we are talking about the generic algorithm, that means that you are generating the custom code for the problem. The second and next is a very, very important step, that is that you have to train the algorithm. And for train the algorithm, we have to know some known data, and that known data that is used in order to train the algorithm. And the third, which is again most important data, most important steps, that when we have trained the algorithm, then train algorithm, we provide some new data and ask the algorithm that predict the outcome, predict the reasonable result. So there are three steps normally that will be used in order to any machine learning model. Now that I have already told you Then the second step, then we have to train the algorithm. Train the algorithm, then we have to provide some data. And by using some data, we will train the algorithm. So what type of data that we can pass in order to for evaluating the machine learning, for train the machine learning? That data can be based on the values. We can also pass some range that is called the continuous data. We can also pass some categorical data, whether it will be a female or a male. Okay. We can also pass the data on the basis of the structured data. We can also pass the unstructured data, that means in the form of audio, in the form of video, in the form of any text that can be passed. We can also pass the data in a labeled form. We can also pass the data in an unlabeled form. When we are talking about the labeled data that consists of both, that input as well as output. And there must be a relationship between these two variables, x1 and x1 and y1, that must be closely related with each other. Okay, the relation can be of anything. We are providing input as well as the particular output. Then we are providing the input. Suppose we have passed x1 and y1. The relationship is father of. So whenever x1 we have passed, so relationship is father of. So x1 is the father of y1. So it will give us the output as y1. When we are providing only input and there is no substitute output of that input that we have passed, then that data is known as unlabeled data. We don't know the output. We don't know the response. We are not labeled the data. Okay? We are just passing the data. So that data is known as unlabeled data. Next, we can also pass the data in form of training data or a test data. Where what type of data we are using for is it we have to train the machine model or we have to evaluate, we have to find the performance of the machine model. What type of data that we are using? Then we are passing the data for training the machine data, and when we are when evaluate the performance of the machine learning model, we use the test data. And normally what will happen, we use the ratio of 70-30, 75 with that 75% data that we are using for the model and 25% for the for evaluation of the machine model. Now we come to what type of machine learning. There are normally three types of machine learning. The first one is supervised learning, unsupervised learning, and the reinforcement learning. In a supervised learning, there are two methods. One is the regression method and the classification method. In an unsupervised learning, there is the clustering method and a PCA. PCA is nothing but the principal component analysis. And in this analysis, we will remove all the features that are closely related to each other. And when we are talking about the reinforcement machine learning model, this reinforcement machine learning what we are evaluating on the basis of the value, policy based. Okay, and there are so many algorithms that are also available, DQN, that is deep network, deep deterministic policy based, asynchronous adversarial algorithm. So now today I will discuss on the supervised learning and the method that will come into the category of supervised learning, linear regression, which is very, very important. Now we come to the category of supervised learning. Supervised machine learning model is the model in which the algorithm that has to be trained on the predefined set of the example. When we are talking about the predefined set of the example, these are the examples that are the training example that we are passing data which is in a labeled. That means we are providing x1 as well as y1, and these x1 and y1 that are closely related with each other. Now we will ask the algorithm to obtain the prediction with the new set of the data. This is what the supervised learning. So in the broad term case, the model learns from the training data set by using the target value as the reference. And the model that can be used, it can be either we can use the regression model or we can also use the classification model. Come to the next slide, that is motivation for learning. Now it is being assumed that there is a relationship that I have already told you, the data that we will provide to the supervised learning is in a labeled form. Labeled form means what? That we are giving x1 as well as y. We are giving the input as well as the output. We are giving the input feature and the target variable, and there must be a relationship between these two variables, input as well as the output variable. Okay. Now see the three graphs that are these are the scatter plotter diagram. The first one, there is a no relationship between the data that I have seen, and the second one provides that there is a negative uh, relationship between them, and the first one, there is a positive relationship between them. The relationship when the variables that have been given to us, x data and a y data, this relationship can be evaluated by the method of correlation. We can also use the Pearson correlation method in order to find the relationship with data. Okay. And in order to find the value of the Pearson correlation method, we will actually find out the value of R. The value of R is in between -1 to 1. Not more than that, not less than that. Okay. So whenever the value of R is equal to 0, that means that there is a no relationship between the values that we have provided. And if the value of R is somehow closely related with -1, it is close to -1, then we can say that they are negative relationship between them. And if the value of the R is closely related with the +1, then we can say that there is a positive relationship between them. What do you mean by the negative relation and the positive relation? When the value of the data that we have provided, if they are moving in the same direction, if the value of x1 is increasing, the value of y1 is also increasing, or if the value of x is decreasing, the value of y is also decreasing, then we can say that there is a positive relationship between the data. And if we are moving in a reverse direction, one is increasing and one is decreasing, then we can say that there is a negative relationship between them. So this relationship can be evaluated, as I have already told you, by the method of Pearson. So correlation of xy can be evaluated by covariance of xy divided by variance of x divided by variance of y. And this covariance can be evaluated by summation of xi minus x bar into yi minus y bar divided by variance of x can be calculated by square root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. What is this x bar and y bar here? X bar and y bar is nothing but it is a mean value of the x data and the y data. Next is a linear regression. Linear regression is a way in order to identify the relationship between two or more variables, and we use this relationship in order to predict one variable for the given value of the other variable. Now, linear regression, the first line is linear regression is used to find out the relationship between the one variable to the other variable. The term that I have used in the previous slide is the correlation. And this correlation is also do the same thing. Correlation is also used for evaluating the relationship between the two variables. Then why we are using this linear regression? Why there is a need of this linear regression when the both does the same thing? Now the answer of this question is when we are applying the correlation, it gives us the nature of the relationship. It gives us the degree of the relationship. Whether it will be a positive relation, it will be a negative relation, there will be a no relation. It only provides the nature of the relationship. But when we are applying linear regression, it gives us the cause and effect. No matter how many data that you have using, but whenever you will apply the correlation, that for the huge amount also, it will just give you the nature of the relationship. It does not able to tell us that which one is the cause and which one is the effect. So that's why we have used this linear regression so that we will came to know about it, that which one is cause and which one is effect. So linear regression is a way in order to identify the relationship between two or more variables. So in order to identify the relationship between the variables, we use a linear equation, or we can say the equation of the straight line. As we have already learned, the equation of the straight line is somehow y is equal to mx plus c, where m is the slope and the c is the y-intercept. So equate that equation in the terminology that y and c I have replaced by w and w naught and w1, where w1 is nothing but it is a slope, that is m, and w naught, it is a y-intercept. And the variable y and x. Y is the dependent variable, and on which it is dependent? It is dependent on the variable of x, and x is called the independent variable. So linear regression we are using in order to evaluate the value of y, that is dependent variable, with the help of the independent variable, that is the value of x. Next is a multiple regression. In the last or the previous slide that I have told you that linear regression is nothing but it is a relationship between the two or more variables. Two or more variables. Okay. When we use only two variables, it will become the linear regression. When we are using more than two variables, then it will become under the category of the multiple regression. Okay. So multiple regression means what? When there is only one dependent variable and more than one independent variable. Now see the equation y is equal to y naught plus w1 x1, w2 x2, w3 x3. So here we have used so many independent variables, that is x1, x2, x3 and so on, xn. So only one dependent variable, that is y. So this is the case of multiple regression. Now we can see this chart, that is we have given the age which is x, and we have also specified the blood pressure under the category of y. When the age is 56, the blood pressure is 147. Now plot this point into a graph, that is scatter plotter. When we have plotted this diagram into a graph, we have seen that all the points that are randomly spread over the each other. Okay, so 56 and 49, 145. We cannot able to define a curve which have been passing through all these points. Okay, so whenever we want to apply the linear regression on that data, so it can be represented as y, that is blood pressure, which is dependent on age, which is dependent on x. So here x, that is age in year, that is the independent variable, and blood pressure is a dependent variable. So this is the equation of the straight line. We have equalized this blood pressure is equal to W naught plus W1 age in years with the equation of the straight line. Now what we have to do, we have to find out the straight line which is best fit into all these points. Okay. Now we have already seen that there are so many points that are spreading over the graph, and suppose we want to pass a straight line that passes most of the points. There are so many lines that can be drawn that can be able to pass these from these points. What we have to do, we have to find out the best fit line. So best fit line is those in which the total error, or we can say the total residual, that must be minimum. Now how would we able to find a total residual, or we can say the total error? Now see this equation of straight line, that is y is equal to x. The error can be represented as e is equal to y minus x. Okay. Now suppose here we can see suppose see the equation E4. E4 is equal to y4 minus y hat 4. What is this y hat here? Why I am using the y hat? Y hat is nothing but the predicted value of the y. Okay, that is y minus x. Now, when you will evaluate this E4 point is at 9th position at the y data, and when you will evaluate this point, it is at the 7th position at the x data. Okay, 7 and 9. These are the coordinates where this E4 lies. So whenever you will subtract 9 minus 7, that is 2. So the value of this E4 is equal to 2. Similarly, you can evaluate the values of the error that are not passed on that line. Okay. Now evaluate the sum of the square of all the errors. You will get the total error. And what your task is that you have to minimize this total error. See the next graph. Here the equation of the straight line is y is equal to 0.457 plus 0.914x. So the error can be represented as y minus 0.457 minus 0.914x. So put the value of x and y data of that coordinate, you will get that error. Similarly, that you have to evaluate the square of the sum of the square of all the error, and what your task is that you have to minimize the total residual, or you can say the total error. So there are methods through which you can find out the best fit line. Okay. The first method is the method of least square, and the second method is commonly used for the optimization problem, that is gradient descent. So we will do one by one. The first method, that is linear regression, is method of least square. Now, as we know that y is equal to y naught plus w1x, w1 plus w1x. This is the equation of the straight line. If I will be able to somehow evaluate the value of the constant variables, that is w0 and w1, then we will be able to find the equation of the straight line. Now, according to the method of least square, there are two normal equations. The first normal equation is this one, and the second normal equation is this one. So, how can we able to find out these normal equations? That first, you have to find out the total residual error, and you have to take the partial differentiation with respect to the constant that is given to us. Put it equal to 0, you will get this normal equation. And the second thing that you can use, the equation of the straight line that is given to us, y is equal to w0 plus w1x. Take the summation both sides, it will become summation of y. Now you are adding w0 with 1 to n. So it will become nw0 plus w1 summation of xi. This will be your first normal equation. Second normal equation, that you have to multiply your equation of straight line with the value of x. Okay. Multiply the value of x both sides, it will become xy. It will become xy is equal to w0 x plus w1 x square. Now take the summation both sides, you will get summation of xi yi is equal to w0 summation of xi plus w1 summation of xi square. So these are the normal equation. You have to solve your normal equation and find out the value of w0 and w1. Okay. Now, the first normal equation, wi is equal to n w0 plus w1 summation of xi. Divide this equation by n. So what will happen? It will become summation of wi divided by n is equal to n cancel. Then you will left with w0 plus w1 summation of xi divided by n. Then you will add the terms divided by the number of terms. It will nothing but it will become the mean. Okay. So this first equation, when you will divide it by n, it will become y bar is equal to w0 plus w1 x bar. Now this will become equation 3. Similarly, y bar is equal to w0 plus w1 x bar. This represents that the regression line always passes through the mean position, always passes through the average position. Okay. Second equation that we have already evaluated, we know that the covariance of xy is equal to 1 upon n summation of xi yi minus x bar y bar minus of x bar y bar. Evaluate the value of summation of xi yi in terms of covariance. Similarly, the variance of x we know we are representing in this way. So by using equation 4 and 5 and substitute the value all these in equation 2, we are left with covariance of xy plus x bar y bar is equal to w0 x bar plus w1 variance of x plus x bar whole square. So when you will use these two equations, you will be able to evaluate the value of W1 and W2. So W1 is evaluated by the covariance of xy and divided by variance of x, and W0 is nothing but it is a y bar minus W1 x bar. When you will able to evaluate the value of W0, simply that you have to substitute this value in the second equation, you will be able to find out the value of W0. Okay. Now the question comes here that why we are using this variance and the covariance. Variance is what when the data is spread from their mean, from the average value, and it is normally used to evaluate the expected difference from the deviation from the actual value. So that's why we are using this variance of x. As we have already seen that in the graph y is equal to x, some numbers are on the upper side of the graph and some numbers are the lower side of that line. So what you have to find out, you have to find out the distance of that point to the line that we have passed. Okay, that line, that distance is nothing. This is but the error. And that's why we have used the variance concept, because the data that we have been spread out from their mean value, from the average value. Similarly, if you are using the covariance of xy, the, the correlation of the xy is used how the relationship, how the x and y are closely related with each other. And the covariance specifies how they are differ from each other. So this is there is somehow a great relationship between these two words. So when we want to evaluate the performance metric for the least square, this can be evaluated by R square is equal to 1 minus 1 upon n summation of yi minus y. Y hat is nothing, as I've already told you about that. Y hat is nothing, but it is the predicted value of y. Okay. So R square is equal to 1 minus 1 upon n summation of yi minus y hat whole square divided by the 1 upon n summation of yi, that is variance of y. Similarly, if you want to evaluate the R square existed value, that can be evaluated as 1 minus 1 minus R square n minus 1 divided by n minus k minus 1. Okay. The next one is the gradient descent. As I've already told you about that, the gradient descent is used for the optimization algorithm. This is the optimization algorithm that have been used in order to train the machine learning model, as well as it has also been used for the neural network. So the model that we have taken is a linear equation y is equal to w0 plus w1x. What you have to do, you have to find the value of w0 and w1. So thus you have to define the cost function. Cost function can be represented by cost. W0, W1 is equal to 1 upon n summation of yi minus y hat. As I have already told you, y hat is nothing but it is the value of y minus W0 minus W1x. Okay, this is how you can evaluate the error. So this is the cost function, and the objective of the gradient descent is that you have to minimize this cost. Whenever we are using the optimization, this is the optimization algorithm. Optimization is always work on the repeated task. Okay. If we have to repeat the task until that we will get the minimum cost. We have to repeat the task. So this is the task that we have to estimate the value of W1 and W0 and W1. This is the objective. And the second objective is that you have to minimize the cost on the basis of the value of W0 and W1. So this is the steps that we have used for the gradient descent. First is you have to initialize the parameter. You have to calculate the gradient of the cost function with respect to the parameter that we have specified. Update the parameter by using the gradient in the opposite direction, and you have to repeat the steps for number of times until that you will get the minimum cost value. So these are the cost of W1, W0, W1. First of all, that you have to, how can we able to find out the cost of the gradient cost function? You have to evaluate the partial differentiation with respect to the constant that we have given to us. As I have already told you, we have also used in the method of least square also. So there are two constants that we have used, that is W0 and W1. So you have to take the partial differentiation with respect to W0 and with respect to W1. Again, you have to update the parameter W0 and W1. Again, that you have to find the partial differentiation until you will be able to get the minimum cost. And if you want to evaluate the performance metric of the gradient-based regression, there are two main methods that have been used in order to evaluate the performance metric. First one is the root mean square error, and the second one is the mean absolute error. These are two methods if you want to evaluate the performance metric. And again, gradient function is also of three types: minimum batch gradients, stochastic gradient. But the main that have been used in the machine learning is the batch gradient or the mini batch gradient that I have already discussed below. So these are the methods. And suppose if you want to evaluate what type of language that we are using, if you want to perform the machine learning, you can also use Python. You can also use R language for implementing. You can also use the MATLAB for the linear regression. IGE, if you are talking about for performing these linear regression algorithms, you can also use the Jupyter Notebook, Julia. These are the methods. These are the IGE for using for evaluating this machine learning. Thank you very much. Any questions? Hello, any questions?
Thank you so much, ma'am. Dear
Thank
participants, if you have any queries, please unmute yourself and you can ask the questions. I repeat, if you have any questions, please unmute yourself and ask the question.
It seems that the participants are happy with the presentation, madam. Sunil Garu will proceed,
Yes,
sir.
yes, sir. Yeah, I hope all our participants are very much impressed with your presentation, ma'am, because you started with the presentation with a linear regression using the machine learning. In that, mainly you focused on what is the machine learning and the type of data and terminology, type of machine learnings, and then you focused with the supervised and linear regression and least square errors. And what is the motivation for learning this, like no correlations, negative, positive, and the relationship measurements. And you already mentioned with the linear regression and the formula for linear regression and multiple regression. And you already explained about you are taking one problem for the formulation, age in years and blood pressures, and there you focused with which line may be the best fit line for your linear regression, and there you calculated the best fit line values with the formulas, and you explained what are the values of x, y, and c values. Then you clearly explained about an interactive session, and you gave a clarity about what is the linear regression and the methods to get the best fit lines and all. At last, you focused with the least square errors and what are the formulas and performance metrics for the least square regression and all. Really, within a short span of time, you covered many important topics which are useful for their research as well as their future enhancement. Really,
Thank you,
we
sir.
are, thank you so much, ma'am,
Thank you,
because
sir. Thank you so much.
in this busy schedule, you spend your valuable time for our participants. We hope the same support will be continued further also, ma'am. Thank you so
Thank
much,
you
ma'am.
very much, sir. Thank you so much, sir. It's my great honor that I am in here, and Mr. Kiran Sri, who has invited me for this FTP. I'm really very thankful to him. Thank you, sir, and thank you all the team members for this Shri Vishnu Engineering College for Women. Thank you so much, the team also.
And thank you very much, madam. It's a privilege actually to see you online. And apart from that, we wish to continue this academic endeavors in future also. We'll collaborate in future conferences and FDPs like this.
Thank you so much, sir. Thank you very much.
Definitely, madam. Thank you. Have a nice day. Bye.
Bye, sir.
Dr. Rajesh, can we start your session, sir?
Sir, okay, sir. Yes, sir. I'm ready.
Thank you. Thank you very much.